hoping to spend a little time talking about the applications of integration. The specific application that I'd like to talk about now is area between curves. And I'd like to find the area between the curves. I'm just going to name these. All came out when I read them initially. They all came out as y equals. But the first thing I would do is I would switch them into f of x form. So the first one was f of x is equal to 8 minus x squared. I named the next one g of x. It was also called y, and it was x squared. And then the author went further and said that also going to bound this by x is equal to 3 and x is equal to negative 3. So I wasn't too concerned about these two pieces at first. I was more concerned about these two. So what I wanted to do was just kind of look at this graph. This is not always possible, and you don't have to do it this way, but I could kind of picture these curves, so I decided to take a look at them, and I figure they look like this. Here's our Cartesian plane. And f of x looks like this, doesn't it? It has the point 0, 8, doesn't it? And it's a parabola. It does that like this. And then down from the other side. Not the best looking parabola ever, but did my best. And this is the point, again, 0, 8. And then g of x is just x squared, so it looks like this, doesn't it? Kind of goes like that. And like this. And I'm not pretending that these are to scale in any way whatsoever. I'm just looking at them and I'm saying, okay, this is what I know right now. What I am wondering now is where is the line x is negative 3? Because if it's in here, we have a different problem, don't we? And if it's out here, we have a completely different problem. So we need to know where these lines are. So what I'm going to do is start off by finding out where do these two meet. So how I'm going to figure the intersection of those two is I'm just going to set them equal to each other. I'm going to say 8 minus x squared is equal to x squared. Just for convenience sake, I'm going to move everything this way so I end up with positive x squared. And if you see how I move everything, I'm going to add x squared to both sides and subtract 8 from both sides. And finally, we'll get 2x squareds minus 8 is equal to 0, right? And that's the form that we want when we're going to solve a quadratic. We want it in this form, not the greatest looking 8 or snowman, whatever you want to decide it is. I look at this, and what I'm looking for is a pattern here because the author's trying to give me something easy to do. So I'm looking at the 2 and I'm looking at the 8, and I realize, hey, you know what? I'm going to factor out. I'm going to take out GCF, right? Greatest common factor is equal to 2. I'm just going to take that out and see what it gives me. And this should have been x squared, sorry. So take 2 times x squared minus 4. And from this x squared minus 4, then hopefully you're seeing this pattern here. Well, what I was hoping to do is change the color of that because, and I did, yay me. But that wasn't what I wanted to change. What I wanted you to see was looking at this, x squared minus 4. That's difference of squares, isn't it? It's difference of squares. So that helped me a lot. So I have this 2 here, and then I'm going to factor this thing, and it's x plus 2 times x minus 2, difference of squares, right, was equal to 0. And now I realize that x is equal to negative 2 and x is equal to 2. That is really, really helpful stuff. It's really going to help me understand what my equation looks like here because guess what the x value is? I don't care what the y value is, but guess what the x value is here? The x value here is negative 2. This is the point negative 2 something, and this is the point 2 something. Why is that helpful? Because look, it really helps me because I want this, now I know I definitely want this area inside here, don't I? I want the area bounded between negative 2 and 2, so I want this area. But it also helps me big time because I had this stuff to deal with, and now I can see where that is. If this is x is negative 2, then x is negative 3 is somewhere out here. So now I can bind this and say this is x is negative 3 here, and look, this is x is positive 3 here. Now I can really see the area I'm looking for. The area I'm looking for is this kind of area in here, isn't it? It's all this stuff. Isn't it? I'm sorry, I'm doing my best to color that in. But that's what I'm looking for, right? So that gives me a better idea of what it is that I want. So I hear people say, well, I guess my next question from here is which graph is on top, because we do definitely want to remember this. When we're finding area, we want to take the highest equation minus the highest equation minus the lowest equation. So we want f of x minus g of x, right? We're saying that f of x is the top one, and g of x is the bottom one. So look here, in this case, we can see clearly right here, right? We can see clearly right here that in this interval, that the 8 minus, right, in orange is the 8 minus x squared one, right? And in green is x squared. And we can clearly see that 8 minus x squared is at the top. Well, how would you know that? If you couldn't see the graph, how would you know that? Well, what I would do is I'd pick a number in this interval, but pick some number between -2 and 2, like 0, and plug it into both equations. And if you plugged it in here, you'd get 8. If you took f of 0 and g of 0, you'd get 8 here, and you'd get 0 here. 8 is greater than 0, and therefore f of x is on top. So where are we going from there? Where we are going from there is here. That now we know we have this. Oh, look, and on the first part, I guess look on the first part, we know in this part that we have x squared is at the top. So we can start setting up our interval here and say, okay, from -3 to -2, from -3 to -2, we want x squared minus 8 minus x squared, don't we? Plus we want from -2 to 2. Now as we look, we can see that f of x is the top function here, and it's this one. So we want this 8 minus x squared, the top one, minus the bottom one, so minus x squared, right? Now what we can do is we can do this part again over here, but we don't have to. So right now, this integral right here solves for this, doesn't it? This one is this one. Let me put my dx's in here. dx. Right? So this piece right here is this. This piece right here is this inside piece. Now we have this third piece. But if you look carefully, this piece right here is the same size as this one. So what I'm going to do here is this. 2 times that area, right? Because I get that area twice. If you don't like it that way, then add it over here again, and it will work out the same. So now what I'm going to do is simply to integrate. So I'm going to integrate here. I'm going to integrate. And we'll get 2 times, oh, actually, let me simplify first. Before I integrate, let me simplify. Let me just simplify here. I want to run out of time. So simplify this. So we have 2. This is going to be x squared plus x squared is 2x squared. So this is going to be minus 8 dx, isn't it? Right? Negative times a negative is a positive. That's 2 of this. That's that. Plus 2 to 2. Right, this becomes negative, so we get 8 minus 2x squared. They're the opposites, and that's what you should have been looking for. That's what you should have been expecting here. Dx here. Now we can integrate, can't we? So now we can integrate. So integrate here. And as we integrate, we're going to get 2. That this 2 is this 2. And as we integrate, we're going to get 2x cubed over 3 minus 8x as evaluated from -3 to 2 plus 8x minus 2x cubed over 3 as evaluated from, well, this is -3 to negative, I'm sorry, from -2 to -3, right? And then here we're going to go from -2 to 2. And finally, to wrap it up, we're going to apply the fundamental theorem of calculus. And we're going to take 2 times f of -2, right, the highest value, minus f of -3, right? and that's this piece right here, isn't it? That gives us the area value here. Now we're going to do this piece here. So here we're going to add the two areas. That's this plus sign right here. We're going to add the area. We're going to take f of 2 minus f of negative 2. I'm not going to do all this math with you because we're going to run out of time here shortly. So let's leave it like this. This turns out to be 28 thirds plus 64 thirds equals 92 thirds, and that is the answer.